So I would like to speak to you about the off button that was pointed in the first panel. So I would like to show you an application and a way to work where people will be using AI in such a way that by using AI, they will become more clever than if they do not use AI. So the fear is that when humans are using AI, their skills could decrease because AI is taking all the decision for the human. And so we are advocating a system, coalitional active learning, where the human intelligence is progressing jointly with the AI. So we call that, and it was my first title, Secure Coalitional Active Learning. So my first message is that we have to put humans together with the AI so that they learn together and they increase the co-intelligence together. And this is the first message that I want to deliver. The second message that I want to deliver is that there are plenty of nice technology in the medical field that can be reused in the field of satellite imaging, and I will show you all that. So, a lot of models are existing in the field of medicine, but they are not that much used. So there is really a need of scaling up the use of AI in medicine. Humans prefer to take their own decision. Analysts looking to satellite image, to bring them the AI system, you need to do things because it's not natural. So, as Pierre-Philippe said, if you want to deploy an AI system, you need a lot of data. You need a lot of data, and to get the more data, the better. So to get a lot of data, you have to bring together data provider, satellite imaging or hospitals providing data, and you can develop a model. So fixed model, large language model, ChatGPT is a fixed model. It's not very convenient because science is always progressing. Medicine is progressing, satellite imaging is progressing. You are doing new hardware every month, every year, there are new kind of satellite, new kind of imaging. So things are moving all the time. And in the field of medicine, like in the field of analysts, second advice is something very important. So people need to be skilled and to improve their knowledge to face this new technology. So analyst people using satellite image, they need to improve their skills continually. And you cannot have a fixed system. And that's the reason why we are promoting coalitional active learning. So when you have image, you have analysts looking to the image, they are providing labels, and the idea is not to have labels from silos, like in a federated learning system, but to put all the experts together to have coalitional labels. And so the idea is to align members on common best decision and to have AI and human expertise continuously improving together. So how can we do that? So if you use ChatGPT, ChatGPT is based on a large language model, and the final step is fine-tuning. You can have a continual fine-tuning of your model. If you do medical imaging or satellite imaging, you can imagine a system, each time you get an image, the AI system is improving because it's getting new data in a continual flow. This is continual learning. And so if you do continual learning, you have an AI system, and it can compute itself the confidence he has when he takes a decision. If the confidence is too slow, you go to the group of experts. And it's the most interesting case because each of these cases are treated by the AI, and only the difficult cases are sent to the human expert. And so the idea is to have this loop sampling the human expert, and to have the idea to have an increase, a joint increase of the human and the brain and the AI together, because the human are asked to the worst case. You have to sample regularly the human expert to improve their skills. And the second advice is also very important to improve the skills. So we are working in this field by using technology, mathematical tools, cooperative game theory to optimize the system and to have the best learning in the human and in the AI. So I will jump above that. One example is mammography in the field of medicine. You have a flow of mammography when you do breast cancer screening, and you can use an AI, and if the AI is not sure, you go for the the expert. So you can go to a pool of experts and to have second advice and learning, co-learning between the people on the most difficult case. We have done it also for treatment, complex treatment, where when you need many type of different experts. For example, in a cancer board, you have the radiologist, the surgeon, the chemiotherapist, how to combine them together. We can use that also. And so finally, we have taken the whole setup and we have done it, we have implemented, and we have a large experiment on the 6th of December with a lot of analysts in Louvain-la-Neuve. We'll put them together to do analysis of airport satellite image, to look at the airport and to see all the strange movement on some specific airports. And so the idea there is to use a pool of analyst experts to have the large satellite image which is cut in tiles. For all the tiles for which we are sure about the decision of the AI, the decision is taken, and all the tiles, the only tiles where there is uncertainty, are sent to the pool of experts. Of course, you need a lot of cryptography behind that because the experts are committed to not disclose the image that are sent to them, but it works. And people are learning more quickly. The analysts are adapting more quickly when you increase the resolution of the image. When you do new technology, the analyst experts are increasing and are learning faster that way. One thing that I want to add, there is a difference between satellite imaging, between these things that we have done and the field of medical imaging. In medical imaging, we have a lot of data. Here we have used game engine and a simulator to increase the data set because we don't have enough data and we need some specific case, some complicated case to be presented to the human expert to train them to detect the things properly. So the conclusion is that we are advocating an implementation of continual learning of the model, which brings a continual training of the human experts and which brings a continually improved decision for all entities participating to the game. So the same concept can be used for medical imaging and for satellite imaging analytics. So there is really a big interest in the field of AI to look to other domains than satellite, and by taking medical technology to a satellite imaging analysis situation, we have done the job. So thank you very much for the listening.
Yeah, I'll take that. Why not? There we go. And now, again, your chance before we go into the coffee break for some questions. Anybody?
Faster.
Yes, there we have a. We just need you to step up to the microphone if that's possible. Yeah. Yeah, but just so once again our remote audience also knows what you wanted to know.
Yeah, thank you for the second presentation. I really enjoyed it, and I have a question to that, to the cooperative game theory. So you mentioned it could be some kind of framework we can use. Can you maybe elaborate a little bit on that, what you meant by that, and yeah, how we can leverage that?
So for the cooperative game theory, we need to set a coalition, and we have to show that if the people are participating to the coalition, they will gain something. So they will take a part of their time to annotate image, they will remove part of their time, and they will allocate this time to the coalition. So they have less time for their own image, but they have to provide annotation for the whole group. So we need to compute a coalitional game. The coalitional game is about accuracy of the final accuracy of the shared model, and also their own skills. So if someone never receives a complicated case, his skill or her skill is decreasing slowly. So we have done a mathematical model of the skills decay. If you don't practice, your skill is decaying. So we can model the skill decay and the gain in accuracy. And combining the gain in accuracy, the skill decay, and a fixed allocated time for annotation, we can compute a coalitional gain. We have also to compute the reward. What is the reward? If you know chaplet theory, we have to compute the reward to give to each of the analysts. And the last thing is to compute the stability of the coalition. If you create a coalition, you need people to be rewarded enough and to have a stable coalition, that the people are remaining in the coalition because they are happy. These are the points that is possible. It's possible to use the mathematical theory of cooperative game to solve this kind of problems.
Does that answer your question? Yeah. You look happy. All right. Looking at the time, ladies and gentlemen, we're going to have to close this session. And we'd like to invite you to a coffee break. But first off, let's give it up for our two gentlemen here on stage. Thank you very much, Pierre-Philippe and Benoit. Half an hour coffee break, and then please be back here on time for the next session with, about sustainability, something you don't want to miss. Thank you for your attention so far.